This program is brought to you by Emory University.
I do sometimes talk about economic policy, about the euro, government debt in the US, the budget. I'm not going to talk about that today unless you bring it up in questions. I'm going to talk about what I got the Nobel Prize for, and it's about economics as science and how sometimes we actually make a little progress in that science. If you, let's see, where's the down? So we're going to talk about a substantive economic question: how does monetary policy affect the economy? And at the start, we're going to set the scene with the state of views in the profession about this question about 50 years ago. On the one hand, there was monetarism that was pushed by Milton Friedman and Anna Schwartz. They thought that monetary policy, in fact, erratic mistakes in monetary policy were the main source of business cycles. They thought that recessions were mostly mistakes caused by bad monetary policy, and that changing policy to dramatically reduce the size and frequency of recessions was straightforward, because if you could just get policy makers to stop trying to improve things and just have them make the money supply grow at a constant rate, the business cycle would drastically shrink. Keynesian economists thought that monetary policy is just one rather small part of the story of business cycles. And in fact, in the early 50s, Keynesians, who were the dominant voice in macroeconomics in academia, tended to think of monetary policy as quite unimportant. This came from the experience of the Great Depression, during which we had been in what Keynes labeled a liquidity trap. It's the same kind of situation we're in now. Interest rates were at essentially zero. There was nothing much the government could do, despite the high level of unemployment and the low level of output. There was nothing much the Federal Reserve could do to stimulate the economy, because interest rates were already at zero, and increasing the money supply didn't really seem to change things very much. Banks were willing to hold lots of money. Keynes had an explanation for why monetary policy was ineffective in such a situation, and that lesson was learned very well by the Keynesians, and they took the view, even in the 50s, when we were no longer in a depression, that monetary policy wasn't very important. So there are two strands to this story, though. One is about learning about the effects of monetary policy and the substantive economics there. And the other is about how economists bring data to bear on theory. Science confronts theories with data. A nice clean science, like physics or biology or chemistry, generates its own data. So if there's a scientific question to be resolved, you do experiments, and if the data from the experiments don't resolve the question, you run the experiment a little longer until there's more data, and you do resolve the question. But economics isn't a nice, clean science. We have to take the data that history gives us, and it only gives us a little bit more every year. In fact, economists take secret delight in things like the great crash of 2008, because at last nature has given us one more experiment. The United States has had 10 recessions since 1950. So in some sense, all of macroeconomics is trying to do science with 10 data points. And 10 is much better than 9. So we're trying to follow two stories that are related: how the effects of monetary policy and the understanding of that improved, and how economists' views about how to get the data to tell us something about this issue improved. So let me start first talking about statistical methods. These macroeconomic statistical modeling began really with Jan Tinbergen, who is a Nobel Prize winner in economics. And he, in the 30s, developed a multiple equation model of the economy. It was in many ways like the modern models that are used in economic policy making. The state of statistical understanding of those models was lower. He just used least squares to estimate equations one by one. He had error terms in the equations. He thought of his model as a field in which you could test economic theories. You could look at how this model fit the data and ask questions about what kinds of economic theory were consistent with it. He was criticized. Keynes hated this model. Keynes did a review of Tinbergen's book. Tinbergen wrote up this model in actually a couple of books. And there was a review done of it by Keynes, and Keynes was extremely negative. Not about Tinbergen. He said Tinbergen is a wonderful man. But obviously, Keynes was extremely bored with reading this book, which was one equation after another and lists of variables and so on. And it wasn't just that he was bored with it. He said that this kind of a model can't answer any interesting economic questions. So I'm going to take a little sidestep here in case, since there are probably many of you who haven't had a statistics course, or at least a good statistics course, to discuss this point a little bit. Hovelmo responded to Keynes. What Keynes said was, we get a bunch of equations in this model. Every equation has an error term. So what is the prediction of this model? The prediction of the model is that the data are going to be what's predicted by this equation plus an error. How would we ever show that anything about this model is wrong? We get some data, we look at the predictions, and then we can calculate what the errors are. How do we ever test whether the model was right or not? The model said there were going to be errors. There are errors. Hovelmo, another Nobel Prize winning economist, wrote a short but extremely influential paper in Econometrica on what was later called simultaneous equations modeling. That was really a response to Keynes's assertion. Hovelmo also wrote a really great paper that was over 100 pages long and took up an entire issue of Econometrica called The Probability Approach to Economics, which is very modern if you read it now. It's really worth rereading. It was on the big issues of how you go about statistical modeling and is good background for understanding what he was doing in this short paper that people more often cite. And this short paper, what he said was, Keynes is wrong. You can test models with error terms. You have to recognize that the way you make models testable, if they are going to make inexact predictions, is that you require that they be probability models, that they explain the nature of the errors you expect, the distribution of the errors you expect. If they're probability models, then you can test them even if they have error terms. So let me give you a very simple example of that. Suppose we're thinking about flipping a coin. It may be a real US quarter that has almost exactly 50% chance of coming up heads or tails. It may not be, though. We're not quite sure. There is such a thing as a biased coin. There are even such things as coins that have two heads on them and so if you're in a carnival or betting with somebody you haven't met before, you have to keep in mind that the coin might not actually be a fair coin. So if you have a model that says, well, one model is this is a fair coin. It's going to be 50% chance of a head or tail each time. This model is not going to let you make low error predictions of whether it's a head or a tail. The best you could do is guess one way or the other every time, and however you guess, this model says you're going to be wrong about half the time. But that's an assertion about what you expect the distribution of error to be. And you could have here's two other kinds of theories you might consider. One is, this is a two-headed coin. It's going to come up heads every time. Either that or it's two-tailed coin. It's going to come up tails every time. That's another possibility. That's the kind of theory that Keynes was thinking was testable. That's a theory that has no error terms. If that theory is correct, that it's a two-headed coin, you're going to predict heads every time, and you're never going to be wrong at all. But you could have another model that said, actually, it's an unfair coin, but it's not two-headed. It's got a head and a tail. It's just that when you flip it, 99% of the time it comes out heads. It's weighted. So that's another probability model. It says if you predict heads, you'll be right 99% of the time, but about 1% of the time you'll be wrong. So now we can have these three theories and ask, suppose we have some data. You flip the coin 10 times, you get 8 heads and 2 tails. So what are you going to say about these three theories? Well, the 4 really, if you count 2 heads and 2 tails. Those 2 heads and 2 tails theories, they're out. You've got 2 heads and you've got 8 tails. Can't be that it's always giving you the same thing. Is there anything you could say about whether it's a fair coin or a weighted coin, if weighted coins are 99% likely to come out one way or another? Well, that's a hard question. If you're a physicist or a biologist, you say, this looks a little bit difficult. Let's flip it another 100 times, and then we'll know. If you're an economist, you say, well, this is history between 1950 and 2012, and it's what we've got. Let's decide what kinds of theories we can rule out and what we can't. So, for example, this describes the probability of getting 2 heads and 8 tails as a function of the true probability. This is the probability of getting a particular set of flips that come out 2 heads and 8 tails. So if we're talking about a fair coin, of course it's clear that with 2 heads and 8 tails, the most likely, if you really knew nothing about where the probability was between 0 and 1, the most likely would be 25%. 25% of your flips have come out heads. The most likely probability is 0.25. But suppose the contending theories really are 1% or 50%. That's tougher. But you can see on this plot that 50% is about here. So the probability of getting 2 heads and 8 tails, if it's 50%, is not that great. It's this vertical axis is not the probability. It's the likelihood. So this is the relative probability of 2 heads and 8 tails. 0.01 is over here. And it turns out the odds are about 10 times as likely that you'll get 2 heads and 8 tails as if you have a fair coin, as if you have a coin that's got only 1 chance in 100 of coming up heads. So this is enough data to tell us if the choices are 0.01 or 0.5, it's likely to be 0.5. It's not enough data to really give us any useful information about p's between about 0.1 and 0.6. In that range, there are different probabilities, but not very different probabilities. We wouldn't really want to rule anything out on the basis of being 2 heads and 8 tails. If we had other theories that are pushing us out here, 80% heads, that's really unlikely. If you get 2 heads and 8 tails, 80% heads as the true probability is really unlikely. So this is inference. This is how you find out, how you make comparisons of models that are probability models, that are making assertions about the distribution of observed data. You're only going to get one set of observations, but you're going to be able to say something, not everything. You can't distinguish all theories, but some theories are distinguishable from one another. And in economics, we're always in this situation. When we do inference with data, we can rule out some things as ridiculous, not consistent with the data, but then there's always going to be a range of views, of theories, that are more or less consistent with the data. So Helm said if we formulate models as probability models, we can test, and he showed how to take a system of equations, a much smaller one than what Tinbergen was working with, and turn it into the kind of graph that I showed you there, the likelihood of what we see based on the parameters of the model. Now, what happened subsequently was that Helm's basic insight that you could take these systems of equations and turn them into probability models for the data, that connected up with what Keynes was doing in his classic general theory book that came out as a way to explain and understand the Great Depression. Keynes had sections of his book that talked about different parts of the economy, and in many of those sections he wrote down a few equations to help understand how the different parts of the economy worked. And people saw that you could, though Keynes didn't do this, people saw you could take those pieces of Keynes's system and put them together and make a system of equations. And you took that insight and what Helm was saying, and it suggested a research plan. So people like Larry Klein, who is another Nobelist, took a bigger system than what Helm had been working with and made it into a probability model of the data. And in the 60s and early 70s, whole teams of researchers, many of them drawn together from top universities in the US, worked on creating quite ambitious models that had all the detail necessary to make them usable in central banks as frameworks for discussing policy. They put together lots of equations. They thought of themselves as using Helm's ideas about how to turn these into probability models of the data. And they ended up with models that were described in books. I have a few of these books. One of them has a pull-out sheet at the back which opens up to be about this size and is full of little boxes and arrows describing all the connections between pieces of the model. No individual human being could really understand how the whole thing worked. And these models began to look not that convincing. Though they were built supposedly on Helm's ideas, in order to make a big system like this work, you had to simplify it. There were too many things unknown in the relation amongst all these variables to ask the data to tell you all the connections. So people put in assumptions. They said, this thing doesn't affect that thing. They said, things this far in the past don't affect current values. They added up assumptions like this that one at a time were sort of reasonable as approximations, but nobody believed they were exactly true. And implicitly what was happening is thousands of assumptions like that were being made in constructing these models. So people thought of them as kind of useful accounting frameworks, but they didn't trust them as to make forecasts. They didn't trust them to resolve issues about economic theory. And Helm's idea, which was that if you did this right, a probability model of the data could be the field on which competing interpretations of how the economy worked played out. You could have the debate occurring in the context of a model. It would be about what the parameter values are and do the data distinguish between these theories or not. Well, as these models were being produced, Milton Friedman and Anna Schwartz wrote their famous book, The Monetary History of the United States. Friedman and David Meiselman wrote an article in which Friedman and Schwartz argued that there was a very high correlation of money growth with income growth. Friedman and Meiselman did regressions, showed you could explain a large fraction of the variation of output of total income, dollar GDP, by looking at the history of the money supply. These big Keynesian models, if they had been what Hovelmo wanted them to be, you could have gone into those models and asked, well, what's the explanation in this model for the high correlation of money with income? But the models weren't trusted for that. And Friedman and Schwartz attacked the models by pointing to these correlations and saying that those models didn't really explain them, the models were overcomplicated, and the Keynesians didn't really have an answer. They couldn't say, look, just look in our model, you'll see the explanation of this correlation is this, but it doesn't really imply that you could fix the business cycle by a money growth rule. That's what they would have liked to have done, but it wasn't an effective debating tactic. There were debates. Ando and Modigliani, who were Keynesians and very active in creating these big models, wrote a very interesting set of responses to Friedman and Meiselman. It's interesting to go back and look at that debate. It was all in the context of using one or two equations at a time. Even though Ando and Modigliani had been active in creating models with hundreds of equations, when arguing with Friedman and Meiselman, they went back to Friedman and Meiselman's playing field, one or two equations at a time. Friedman and Meiselman claimed that money explained income better than what they called autonomous expenditure, which they claimed was what would be a Keynesian's view of what determines income. Ando and Modigliani said it's not so clear that that's what a Keynesian would claim. They made a lot of good points in response, but the important thing for us is they did not go to their big model and say, we can explain your results with our big model. The big models were turning out to be a kind of dead end. So I guess I'm back to my paper notes at this point. So the Keynesian response to Friedman and Meiselman and Schwartz had two stages. Initially, the Keynesians were surprised that the correlation of money and income was so big. They had thought of monetary policy as really not that important. I found a quote from Alvin Hansen, a book he wrote in the early 50s. I think it was early 50s, may have been early 60s. He wrote a book on Keynesian economics that said, Keynes taught us that monetary policy is a handmaiden to fiscal policy. It has some effects, but most serious modelers do not give it a major role. That was the Keynesian view. So the fact that the correlations turned out to be so high was a little puzzling. Jim Tobin, another Nobel Prize winning economist, wrote a paper explaining how high money income correlations could arise even in an economy where monetary policy errors had nothing to do with generating business cycle fluctuations. But his model wasn't a probability model, and he didn't use any data. He just set up a very simple theoretical model in which money was passively responding to other things that happened in the economy, and showed in this, and then he perturbed it with sine wave fluctuations in disturbance terms, and showed you got out sine waves for money and income that had the same relative size and same timing pattern that Friedman and Schwartz and Meiselman were claiming showed that money caused income. But this is another example of the Keynesians not going back to what should have been their fortress, which was the big models, but instead finding new ad hoc ways to go back at the monetarist. So the first thing I contributed to this debate was a paper called Money, Income, and Causality in the American Economic Review. The idea of this paper was that if you had two time series, money and income, and you thought one was causing the other and without any reverse causation, which was more or less the claim of the monetarists, that it had implications for the statistical behavior of those two series. Now, when I had to talk to a bunch of high school students in Stockholm about this. So I used this example. Some people think it's amusing anyway. This seemed like a really good example in Sweden in December. Maybe not so good in Atlanta in April. But suppose you are a biologist and you've put GPS tracking chips in a moose and a wolf. And you know that the moose is being tracked by the wolf, and the moose doesn't know that the wolf is tracking it. At least that's your theory. You've got data on the GPS coordinates, but unfortunately you've lost track of the serial numbers of the two chips, and you don't know which one is which. Can you tell, just by looking at the locations over time of these two beasts, which one is aware of the other and reacting to it, and which one is just wandering around? And it turns out that you can. That's basically what my contribution was. You think of the monetarists as claiming that money is like the moose. It moves around for no good reason and affects the income, and any random fluctuations in income don't feed back, just as random fluctuations in the wolf's position don't feed back into making the moose go in a different direction, because the moose isn't even aware the wolf is there. So that's what I did. I took that insight that you ought to be able to tell the difference, and I tested the regressions that Friedman and Meiselman were running and showed they passed this test, that money behaves like the moose. It looked like it confirmed their view that a large part of the business cycle was explained by random fluctuations in money growth, and this made a pretty big impact. Not on Milton Friedman. Friedman, I gave this talk at Chicago shortly after I wrote this paper. Friedman had recently had a heart attack and wasn't at the seminar, but he was so interested in it that he asked that I be brought to his hospital room, where he told me that he thought that what I was doing didn't really contribute anything new compared to his own study of timing of the cycles. I didn't agree. I tried to explain it to him without getting him upset, since he just had a heart attack. But it actually was a great honor that he was interested enough in this to tell people to grab me and bring me over so he could grill me. But it turned out that I was wrong, and Friedman was wrong. And the steps by which that became clear to me started with a former student who, after he had left Minnesota, took up the question of applying my ideas to the money demand equation. People at the same time, Friedman and Schwartz, were estimating equations in which they explained income with money. A lot of other people were estimating what were called money demand equations, explaining money with income and interest rates. It seemed like it couldn't be right that money demand belonged on the right-hand side in one of those and on the left-hand side of the other. In other words, that causation was going from money to income, and at the same time, if you looked at a money demand equation, which differed only in that it added one extra variable, the interest rate, it was income and interest rates that belonged as driving forces for money. So Mera found that actually it was true. If you did these tests, the moose-wolf tests on both equations, they both passed. And I decided somebody had to estimate two equations together and understand how the whole thing worked. And so I started doing that, and after I started doing it, a lot of other people began to get into the act. And there were a variety of new methods I won't try to describe in detail that were brought to this, but essentially 4 main variables were modeled jointly: interest rates, money stock, price level, and income. And we found ways, actually many different ways, that gave the same answer to sort out the joint movements of these variables. The problem is interest rates and money and income all move around for lots of different reasons. When the Fed tightens, we think interest rates go up and that pushes money down and prices down and output down. But when the economy booms, that pushes money up and interest rates up and prices up. And there are other kinds of disturbances in the economy that create relations amongst these variables, and they're all operating at once. And the problem is to sort them out, to try to separate movements in these variables that come because of shifts in policy from movements in these variables that come from other sources, so we can get a picture of what the effects of policy on the economy are. And this group of people who worked in this area got a pretty consistent set of answers eventually to those questions, and they showed that the money income regressions were misleading, that in fact, I'll just describe the conclusions of this literature. Monetary policy does have effects on the economy. It has effects in the directions you would expect. A monetary contraction raises interest rates. It pushes down the growth rate of money. It pushes down output growth, and it pushes down, with quite a long delay, inflation. But these effects are not the main source of business cycles. They explain something between, depending on what country and what period you look at, they explain maybe something between 0 and 30% of the variation we see in real GDP and inflation. Most of the business cycle is coming from other sources, and most of the movements in interest rates that we see and movements in the money stock we see are not random errors by the monetary authority. They're systematic responses by the Fed to the state of the economy. The Fed is constantly monitoring inflation and unemployment and trying to judge what's the state of the economy and what would be the right thing to do with monetary policy. And it's not that it's only been doing this since 1990 or 1980. They were doing that even back as early as the 60s. So the conclusion is most fluctuations in interest rates are systematic responses of policy. They're not, and most movements in the money stock are not random policy errors. And in that very important respect, Friedman and Schwartz were wrong. You have to keep this in perspective. In this perspective of the Keynesianism of the 50s, Friedman and Schwartz were right. Monetary policy was important, and the Keynesians were completely ignoring it. And Friedman and Schwartz very forcefully made the point that monetary policy matters. But they went on to say that the only way it matters is that policymakers continually make errors, and it would be better if we just tied their hands and forced money growth to be constant. There's no support for that in careful modeling of the effects of monetary policy. In fact, it's clear that most variation in monetary policy is systematic response to the state of the economy. So it's not at all clear. In fact, it seems quite likely that any attempt to force the Fed to start doing something much different, which would be just keep money growth constant, could actually have really bad effects. They weren't just randomly pushing the money stock around. They were systematically responding. And unless you have a clear idea about why their systematic responses were a mistake, you may be making a big mistake by forcing them to change to some simple money growth rule. So that's not really the end of the story, though, because the models that were used to sort out the effect of monetary policy that I've been describing were fairly small models, and they were focused on this one issue. Let's see if we can pull apart monetary policy effects from everything else. And they didn't try to figure out what everything else was. They just wanted to separate these two things and get an answer to the question that was the big issue in the 50s. But policymakers at the Fed or the ECB or central banks in general aren't interested only in tracing out the effects of monetary policy. They're interested also in contingency plans. They want to know what would happen if the oil price went up because of a supply disruption. One question that was at the top of policymakers' minds in the 90s is, has the rate of advance of technology increased in a permanent way? That's a question about disturbances arising outside of monetary policy and a particular class of disturbances. It mattered whether the growth we were getting was because of technology growth and a permanent shift in technology, or whether it was coming because demand was pumping up GDP growth. They wanted an answer to that, and that was a question about what's the source of variation that we're seeing in the economy, given that it's not monetary policy. Well, models that can do that are harder. They require making stronger assumptions. In fact, they require, if you really want to get an answer to questions like these models are built to answer, you're going to find different models with different assumptions all fit the data fairly well. And what we'd like to see is competition between models with different implications, all of which have been carefully vetted to be good probability models of the data. What we've actually succeeded in doing, first, people who were trying to construct these kinds of models, which are called structural models, and now a lot of them are labeled DSGE for dynamic stochastic general equilibrium models. The first step in this was simply to take the results that were coming from this vector order regression literature, the literature that just separated money from other sources of disturbance, take those results about how monetary policy affects the economy and try to build a model that's more complete and gives more complete stories about sources of variation that preserves these accepted facts about the way monetary policy affects the economy. And the first people to do that were Cristiano, Eichenbaum, and Evans in a famous paper. They didn't actually, this was not really a complete probability model. They didn't fit most of the parameters statistically. They just tried to match these facts that were coming from the statistically fit vector order regression literature. And then a couple of guys in Europe, Frank Smets and Rafe Wouters, decided you could actually take this model and do what Hovelmo wanted to do at the start. You could actually make it a probability model for the joint behavior of the time series. And they succeeded in doing that. And once they showed it could be done, it generated imitators in central banks all over the world. These models have, in a few central banks, this style of modeling. In a few central banks, it's become the main policy model. In most central banks, if it's not the main policy model, there's something alongside the main policy model with a research group working on it. So to me, it looks like we have a picture of progress both in our understanding of how monetary policy works, and this progress was generated in part by improvement over time in our formal methods for connecting data to economic models. And we're now at a point where you could say Hovelmo's dream or idea is realized, except there are lots of things wrong with these models still. And if you want to look more into this, you can look at my webpage or the Nobel Foundation webpage, which have the slides from my talk in Stockholm and a more extensive written up version, which go into all of what I've discussed in considerably more detail, fill in some technical background, and give references. And one part of those slides and that paper is a section that critiques these DSGE models. We know now, in hindsight, that they paid too little attention to the possibility of financial disruption. It hadn't been that important historically, and so when you had a complicated model to build, it was an easy choice to kind of leave that out, and that turns out to have been a big mistake. It's also true that if you look historically, there have been regularly periods where unexpectedly large disturbances arose. Of course, that happened in 2008, but it's happened before, not quite so big, but bigger than the models would have predicted. In this sense, the models are problematic from Hovelmoe's point of view. The model's views of what the likely distribution of errors was already saying before 2007-8 that big errors are happening too often. We should have paid more attention to that earlier. Most of these models have very skimpy modeling of public finances. We all know that the big policy issue in the US is the deficit, the future, how we're going to finance future Medicare and Social Security, how that feeds back into current decisions about spending. All of these things are related to monetary policy, and the current crop of models does not do a good job of making those connections. So there's lots of reasons to think that these models can be improved. Lots of people are working on improving them. In a way, it's encouraging that there's all this work. It's also a little frightening that we have over and over again been a little bit behind the curve, and you hope we're not going to be as far behind the curve the next time. So I'll stop there. Take questions.
Can you speak a little bit about what does affect income, whether it's nominal income? If I heard you right, you said it's probably 0 to 30% based on monetary policy, and the Keynesians probably would have been happy with that in the 1950s, and then things swung the other way. Is fiscal policy a lot of that 70 to 100%? Are technology shocks a lot of it? Financial crises, that kind of thing?
Well, you have to, I didn't really talk about what it meant to say 0 to 30% is monetary policy. That's assuming monetary policy is going to continue to react to the state of the economy in the usual way. How much of it is erratic changes in monetary policy that deviate from the normal pattern? The normal pattern is inflation goes up, the Fed gets worried and raises interest rates. That's happened regularly over and over again. So the 30% is saying, well, it's probably 20 or 15. The small proportion is saying the times when interest rates rise more than you would expect from looking at inflation and unemployment, or fail to rise as much as you would expect, that doesn't explain a whole lot. That doesn't mean there wouldn't be huge effects on the economy and the business cycle if the Fed started behaving in a completely different way. It's not to say that monetary policy can never have more effect than this. In fact, what you would say is the ideal monetary policy would perfectly read the state of the economy and optimally respond at every moment, in which case monetary policy, by the measure I've been citing, would have no effect on the business cycle. But of course, this perfect response presumably is having an effect is probably keeping the business cycle narrower and milder. And you can take these models and ask, well, what would happen if you do something drastic, like say the Fed pegs the interest rate and never moves it, or the Fed responds twice as strongly to inflation as it has historically. Would that make a difference? The answer is it makes a huge difference. If they respond much more strongly, you get bigger business cycles, narrower fluctuations in inflation. If they try to peg the interest rate, these models will say you'll get explosive behavior of the economy. So monetary policy could explain a lot. Now, given the way it's actually behaved, your question was, well, what's the other 70%? It's not necessarily policy. We have a pretty stable economy. You're getting shifts in technology, as you mentioned, internet, microchips. These things are making big changes in production possibilities, and they don't occur in a perfectly even way. Some of the business cycle is that. And we had the internet boom and then bust, and it didn't have the kind of effects on the economy that the housing boom and bust did, but it did disturb the economy. And so that's in some sense a technology combined with financial friction story. So there are lots of candidates for things that can make the economy fluctuate other than monetary policy or fiscal policy.
Following up on your comment about asset prices, my question is, given the downturn that we've had, it would seem like you could argue that two endogenous things contributed to the depth of our downturn. One is asset prices perhaps bubbling beyond what fundamentals would submit. The other would be whether we have a leverage cycle, which we kind of have some theoretical work now about households and leveraging up, leveraging down. Are you hopeful that going forward we could focus more on that? Do you think that was perhaps one of the weaknesses of our models, that we didn't really model that kind of behavior explicitly before?
The simple answer is yes. I think it's difficult to do that modeling well. Financial variables can have strong correlations with what's going on in the real economy that aren't stable. If you look back at the time when Friedman and Schwartz were at the peak of their influence, when Congress was passing laws requiring the Fed to quote monetary growth targets and report to Congress if it missed, the financial markets were responding every week to the monetary growth reports, how much M1 was moving. That correlation was very strong. It's completely gone now. Even the correlation of stock prices with real variables will change rather drastically between one decade and another. I think the reason for this is that that markets are full of people who have theories about the way the economy works, and those theories shift. And so they think that this variable is really important for predicting future profits, and they respond to it, and then it begins to not work so well, and they shift to something else. And the correlation can be high while it lasts and then go away. So that's a worry in doing this modeling, that we end up sifting through the financial variables that are in the data, finding something that seems to have predicted the last recession, and end up having a model that is very good at fighting the last war but not so good at fighting the next one.
Hello, Professor. I have a quite mercantilist question, as I'm an MBA student. When do you expect Fed start hiking the rates?
Well, as the Fed has said, it doesn't expect to begin raising them a lot before late 2014. And so I think that's the way they arrive at that kind of statement is by running their models and having the guys, having the people on the FOMC. There's more than one model. There's the Fed's model, but the different regional banks have their own models, and they put together these models and figure out when is unemployment going to be down enough and inflation picking up enough so that we're likely to feel like it's important to raise the interest rate. And I don't have 10 models with 4 research assistants each running them, so I'm not going to try to second guess them on that. I think their prediction is probably pretty good. Of course, it's really contingent. They don't emphasize this so much, but of course, if inflation shot up to 6% next year, you can be pretty sure that the interest rates would go up, even though it isn't yet late 2014.
Dr. Sims, I have a question about one of the comments you made earlier. Science with 10 data sets, data points. I guess in like the biology or.
Yeah, is the mic working?
Yeah.
It's for the recording.
Oh, it's just for the recording. Okay, so just speak up.
Okay. So I guess in biology and physics, someone could just run more the tests longer, but the data sets for those are, I guess, independent of each other. But could you say the same thing for economics? Because based on the data now, if they create some economic policy, wouldn't that affect the future data sets? So wouldn't they wouldn't be completely independent?
Yeah, it's worse than I said. It's not just that we don't have much data. It's that a good experimenter who didn't know how important monetary policy was would say, okay, let's try lowering the interest rate when inflation goes up and see what happens. The Fed is not going to do that because we think, even though we're not actually sure, you can construct models in which that could even be a good idea. But nobody thinks those are the most likely accurate models. So the problem is that we get data, and the data aren't generated by experiments that are controlled, where we push around the factor whose effect we're looking for and see what outcome comes out. We have to look at data in which the things we're interested in are being pushed around for all kinds of reasons, and that's why this problem of figuring out what are monetary policy effects was so hard, and why it took us a couple of decades to get it all sorted out.
So actually, I would take an issue regarding the fact that economics cannot be a science the way that physics or biology are. I'm an experimental economist, and probably Vernon Smith will disagree with what you said about economics. We cannot actually generate control environments where we could test how people will behave, but indeed we can. And there is a group of people at Pittsburgh with John Daffy, who has been doing some experiments for macroeconomics. And actually, when I was in grad school, I came across a paper, a really rare, like a 2-page paper written by Robert Lucas, where he was actually suggesting to macroeconomists that they should look carefully about how they have been doing macroeconomic analysis, just looking at historical data, and possibly look at introduce experiments for seeing, for example, close down a kind of an entertainment place, and then where people are exchanging chips for some type of services, and then increase the value, increase money supply, and do those types of experiments to see what happens. So I was interested in seeing your view about, and hearing your views about whether actually you can have experiments in macroeconomics. Clearly, when we are looking at individual behavior or strategic behavior, we can do these experiments. But when we are talking about more complex interactions, what's your view regarding that?
There's no doubt that economists can do experiments and we can learn from them. But I think the chance for learning about price level determination and monetary policy is fairly slim. There are some examples of natural experiments. There's a great paper by Francois Velde, V-E-L-D-E, in the JPE about a sequence of policy moves in France, I think in the 18th century or 17th century, where they had a coin that was the unit of account, the livre. And a couple of times they changed how much silver was in the livre. So you had to bring in your old one, you got a new one, and it would have, one livre would have less silver in it. Everybody knew this was happening. It was happening on a certain date. It was the perfect example of a change in units shouldn't have affected anything. You should have immediately have gotten all prices going up by the percentage by which the amount of silver in the livre went down. It actually worked exactly this way on the foreign exchanges. If you tried to change a livre for something else from another country, the people in the other country knew exactly what should happen to the relative price. But it didn't happen to prices of goods in the marketplace. They moved smoothly and slowly. So that's an example that shows us that it's not just that nobody understands what's happening that makes prices sticky and responses of prices to monetary policy move slow. But this is like another 3 data points. And I think what happens if you get groups of 10 or 12 or 40 students and do this kind of thing, it can give you some insight, but you wouldn't want to rely on it for making monetary policy. There are some great experiments that I always assign to my students in money and banking, and of course I teach on bubbles and crashes by Smith and some co-authors, where they took groups of students and gave them artificial securities that pay off with 50% probability each period. You either get $1 or nothing if you hold 1 unit of this security. You endow these different students with different amounts of these securities. You can say you allow them to trade them. They do trade, and you find most of the time the price starts out below. There's a certain number of periods, like 20 periods or 40 periods. So you'd think if they had any sophistication, if it's going to be 40 periods and there's 50% chance each period they're going to pay out $1, it should be worth about $20. Well, it tends to start out below $20. Starts to go up. People realize that if you have this stuff, you're not only getting the $1, you're getting appreciation, capital gains. Price goes up even faster. And then it gets to be about 6 or 7 periods before everything's going to shut down, and people realize this is going to be worthless after the thing shuts down. There's only 7 more periods to collect anything. Everybody's going to be desperate to sell in the last period, even if the price is way above fundamentals. So the price comes back down. So you get a boom and bust. Now, of course, the trouble with this is that if you take the same group of students and do it 3 or 4 times, it stops happening. So what does this tell us about asset markets? If you have a lot of naive people coming in, you can get booms and busts. Maybe if people are more sophisticated, it's not so easy to get the booms and busts going. They're interesting results, but they're not going to give us answers to direct policy issues. One other set of experiments that's really fun to look at is a paper by Sargent and can't remember the name of his co-author, a woman at Vancouver or Simon Fraser. They got bunches of students and had one be the monetary policy maker. And they set up a Keynesian Phillips curve, a natural rate Phillips curve, where you can get unemployment down if you can surprise the public with inflation. So the other students are the public. They get paid for accurate forecasting. Policymaker gets paid for getting unemployment low. And he can get unemployment low by surprising them with inflation. But of course, if he does it very many times, it's not a surprise anymore, and unemployment comes back up. And the results are very interesting. for one result is that the inflation starts out a little bit positive, but then goes very smoothly down to almost zero. So the monetary policy looks like about as good as you could expect in most of the trials. But then there are a few trials where the policymaker tries to figure out how to keep surprising people. And the inflation goes whap, whap, whap all over the place. And unemployment is going up and down. And then after a while, the guy realizes this is not getting him anything. So he tries to revert to the policy that worked so well for everybody else. He sets inflation fairly low and makes it slowly start going down. But the public keeps expecting that he's going to do this again. And so the fact that he's keeping inflation low is constantly a surprise, and it results in unemployment being high. So these are very interesting experimental results. I think they give you some insight. They tell you that if you really blow your reputation, it can be very costly. They also tell you that it's surprisingly easy to establish a reputation. It doesn't really fit with any game theoretic framework. For some reason, people seem to be very ready to believe that a stable policy is going to persist. So there's lots to be learned from experiments. I don't think we should shut them down at all, but I think the idea that they're going to replace the kind of modeling we do where we look at the historical data is not correct.
Okay, well, I think we have time for probably one more question, and then I'm going to have to let him go.
I have a very simple question, I think. I was just going to ask, given the severity of the recent crisis, do you really think that the natural rate of unemployment has permanently increased and that any monetary and fiscal policy will not actually help the economy improve and regain that natural rate?
It's actually a regularity in U.S. economic history that whenever unemployment goes up, there are economists who produce theories that explain that this is because of mismatch of workers to jobs or a permanent shift in the economy. This is a way to justify not trying to do anything about it. And in fact, if you look at the US, the economy is picking up now. Our economy is doing better than England and ECB, than the Euro area, which have both been more restrictive. I think that it's pretty easy to claim this was mostly a demand-driven rise in unemployment. It's taking a long time to unravel. There's historical precedent that financial crisis recessions take a long time to recover from, but we seem to be moving in the right direction. I don't see any real reason to think that we have to settle for an unemployment rate that's much higher than we used to consider normal.
The preceding program is copyrighted by Emory University.